In a past video, we covered how to construct a confidence interval for a population mean when the population standard deviation is known. Real quick, we use the formula x bar minus z alpha over 2 times the population standard deviation over the square root of n less than mu less than x bar plus z alpha over 2 times the population standard deviation over the square root of n. In this formula, sigma is the population standard deviation, which is known. So to use this formula, we need to know the population standard deviation. However, in most cases, the value of the population standard deviation is unknown. And when it's not known, we use the formula x bar minus t alpha over 2 times s over the square root of n less than mu less than x bar plus t alpha over 2 times s over the square root of n. In this formula, x bar is the mean from a sample, s is the standard deviation from a sample, n is the size of the sample, t alpha over 2 is a t-score based on the confidence interval we're using and the degrees of freedom. And the degrees of freedom are equal to n minus 1, the sample size minus 1. And mu is the population mean, which is unknown. And to use this formula, the sample must be random, and the sample size must be greater than or equal to 30, or the population must be normally distributed. The t-distribution is actually a family of curves, which are determined by the degrees of freedom. For instance, here's an example of a t-distribution where the degrees of freedom are equal to 2. And here's a t-distribution for 5 degrees of freedom, and here's a t-distribution for 20 degrees of freedom. And now here's the standard normal distribution, or z-curve. If we put them together, you can see as the degrees of freedom increase, or as the sample size increases, the t-distribution approaches the standard normal distribution, the z-curve. And we will use the symbol d.f. for the degrees of freedom. Just like in the standard normal distribution, or z-curve, the t-distribution has an area under the curve equal to 1, the tails never touch the x-axis, it is symmetric about the mean, and the mean is equal to 0. Unlike the z-curve, which has a standard deviation of 1, the standard deviation for a t-distribution varies but is greater than 1. As far as the 90%, 95%, or 99% confidence intervals, they have the same concept for a t-distribution. For instance, for a 90% confidence interval, for a t-distribution, we have 45% to the left of the mean, 45% to the right of the mean, which is the actual confidence interval, and 5% in each of the tails. And just like with a z-score, we would look up the t-score in a t-distribution table. And here is a t-distribution table, which can be found through an internet search or in any statistics book. And for confidence intervals, we will use the top row under the 90% column. Say our sample size was 24, then the degrees of freedom, n minus 1, would be 24 minus 1, or 23. So under column 1, df, we would go down to 23 and over to the 90% column, and we get 1.714, which is the t-score. And going back to our formula, we would plug this value, 1.714, in for t alpha over 2. Let's do an example. So let's say that you put together a random sample of the time customers spend having dinner and taking up a table at a fancy restaurant. The sample had a mean of 88 minutes with a standard deviation of 17, and your sample size was 14. And we're going to assume the population is normally distributed. Find the 95% confidence interval of the population mean for the time spent at dinner. Using our formula, we have x bar equal to 88, s, or the sample standard deviation, equal to 17, n, the sample size, is equal to 14, and for t alpha over 2, we have a confidence level of 95%, and the degrees of freedom equals n minus 1, which is 13. In the t-distribution table, we go down to 13 in the df column, then over to the 95% confidence interval column, and the value listed is 2.160. So this is our t alpha over 2 value, and our formula is complete. Plugging and calculating, we get 78.2 less than mu less than 97.8. So we can be 95% confident that the population mean is between 78.2 and 97.8 minutes based on a sample of 14 customers. Alright my friends, that be the basics on finding a confidence interval for the mean when you don't know the standard deviation. Hopefully this video helped you out. I do have more videos right there for you. Till next time, I am out of here.